Hello everyone. In this video I will revise with you two lessons, matrices and logs. Okay, first in matrix, you know that the matrix like 3, 2, 1, 0 or -5, this matrix is two rows of two columns. Okay, this 3, 5, 2, -5, this matrix we need to add it to, for example, 1, 2, 0, -3. If you want to add or subtract, this first add. When we add or subtract, we take the corresponding elements like 3 and 1. So this is 4, 5 and 0, which is 5, 2 and 2, which is 4, -5 with -3, which is -8. If it's subtraction, as you see here, we subtract also corresponding elements like 3 and if it's addition, it's done now. This is the answer. If it's subtraction, do the same. 3 minus 1, the answer would be 2. 5 and 0, it's 5. 2 minus 2 is 0. -5 minus -3, it's +3, so the answer is -2. So this answer for addition and this answer for subtraction. And of course I will ask you about one thing only in the exam. Okay, sometimes we need to multiply a matrix like this, 3, 2, 1, 5, 0, -8. We need to multiply this matrix by this scalar value. Okay, we need to multiply by 3 or 2 or any scalar. In this case, when we multiply by scalar, we distribute like we do in polynomials. So 2 times 3 is 6, 2 times 2 is 4, 2 times 1 is 2, 2 times 5 is 10, 2 times 0 is 0, 2 times -8 is -16. And this matrix is two rows of three columns. You don't have to write this. Okay, we see this part is very easy. Okay, but when we multiply two matrices, we do like longer steps. For example, if we have 2, 3, 1, -2, 0, 5, -2, and 3. Okay, to multiply, we take the first row and multiply it, the first by the first column, then second by the second column. After we finish this, we take the second row to multiply it first by the first column, then multiply it again by the second column. How can we do this? I'll explain now. So when we take the first row to multiply it here by 0 and -1, we take 2 times 0, which is 0, and 3 by -2, which is -6. We don't distribute 2 by 0 and 2 by -2 now. We only multiply 2 by 0 and 3 by -2. After we finish the first column, we multiply the first row with the second column. 2 times 5, which is 10, 3 times 3, which is 9. Now we have finished the first row. Take the second row. 1 times 0 is 0, -2 times -2, it's +4. We have finished this. Now take this. 1 times 5 is 5, -2 times 3 is -6. Then simplify to get the final answer. -6, 19, -1, 4. This is the final answer. Okay, we may need a different example. For example, 2, 2, -1, 3, -2. We need to multiply this 2 by 2 matrix by 3, 1, 2, 0, -1, -2. Okay, this is 2 of 3 matrix. Can we multiply this? Yes, we can multiply this because you have the inner values are equal, so it's easy to multiply these two matrices. How? Following the same instructions. The first row, first by the first column, then the second column, then the third column. Let's do this together. 2 times 3, 6. Negative 1 times 1, negative 1. Okay, second. 2 times 2, 4. Negative 1 times 0 is 0. The third one. 2 times negative 1, negative 2. Negative 1 times negative 2, positive 2. Okay, we have finished the first row. Let's go to the second row. 3 times 3 and negative 1 times 2. It's 9 minus 2. 3 times 2, 6, and negative 2 times 0 is 0. 3 times negative 1, negative 3, and negative 2 times negative 2 is positive 4. Simplify, put the answer in simplest form. 5, 4, 0, 1, 6, 7. This is how to multiply two matrices. Then we have the determinant. The determinant, if we have 2 by 2 matrix, 2, 5, negative 1, 3, or 1 and 3, how to evaluate them, how to determine the value of this matrix or the determinant? We cross multiply by subtracting. So 2 times 3 minus, it's always minus. 1 times 5. So the answer will be 6 minus 5, which is 1. Different example. 5, negative 2, 3, 8. Or 2. 5 times 2 is 10. Minus 3 times negative 2, it's negative 6. Now, so the answer is 16. This is 2 by 2 matrix. We need to evaluate the determinant of 3 by 3 matrix. For example, 5, 2, 0, 1, 3, negative 2, 1, 3, 5. Okay, before we start, okay, to evaluate the determinant, we did here, we have 4 elements, we cross multiply only, but here we have 9 elements. Can we use the same method? Yes, but we will do the same as we did here 3 times. First of all, you decide to take one row or one column. We usually use the first row. It's up to you. You can choose the second row, the third, or the second column, third column, first column. It's up to you. Okay, let's apply this to the first row to make it easy first. Before we start, each element of the matrix has a sign. This is, we start always by positive, then change negative, positive, negative, positive, negative, positive, negative, positive. When you choose to take the first row, neglect the other signs. Okay, and we will have 3 brackets. 5 multiplied by a bracket, then negative 2 multiplied by a bracket, then positive plus, not positive, plus 0 multiplied by a bracket. So next, what to do? Okay, to find what's here, for this 5, cancel this row and this column. Now we have 4 elements, and we do like we did here. 3 times 5, 15, minus negative 2 times 3, it's negative 6, so it's positive 6 plus 6. Now for this, negative 2, cancel this row and cancel this column. 1 times 5 is 5, minus negative 4, which is plus 4. Then the last one, when we cancel this, whatever the answer is, 3 minus 6, but it's multiplied by 0, so this bracket will be cancelled. So the answer is 21 here, multiplied by 5, it's 105, minus 9 times negative 2, it's negative 18, so the answer is 87, maybe 87. Okay, you can make sure of the answer. Okay, in the beginning I told you that you can choose whatever row or the column that you need. Okay, let's try for example this first column. Okay, this is positive, negative, positive. Will it give us the same answer? Let's try. 5 minus 1 here and plus 2. 5 multiply, it's 15 minus positive 6. Negative 1, 2 times 5 is 10, minus 0. Okay. 2, it's positive. This is positive 4, sorry, it's negative 4, minus 0. Okay. This is 105 minus 10, and this is minus 8. Will give us the same answer? Yes, 105 minus 100 minus 18, it's also 18, so the answer is 87. So you do it by only one method, but I'm just repeating or doing two methods to make sure that whatever you did, you'll get the same answer. Okay, last thing in matrices, and let's move or take the logs in a different video. Okay, matrix. If we need to find the inverse, 2, 3, 1, and negative 5, or 2, let's make this here. Okay, what's the inverse of this matrix? The inverse, we get the inverse by two methods. The first one is to evaluate the determinant. 2 times 2 minus 1 times negative 3, which is negative 3. It will be positive 3. So it's 4 plus 3. So the answer is 7. If you are confused, go back to this. We are doing the same here. Cross multiply with minus. So we did the same here. Cross multiply with minus. So it's 7. So the answer, the first part of the answer is 1 over 7. It's always 1 over the determinant. It's always 1 over the determinant. Then rewrite this matrix, but with some changes. You replace 2 with 2. Okay, it will not be clear in this example. And keep this and change its signs. So this will be positive 3 and this will be negative 1. But we replaced this 2 here and this 2 here. Okay, let's do a different one to make sure that you understand clearly and not be confused of like same numbers. 5, negative 2, 3, and 4. 5 times 4 minus 2 times 3. So it's 20 plus 6. So it's 1 over 26. Changes 4 and 5. The main diagonal, we change the number, the elements, and for this keep the 2 and 3 but change the signs. This will be negative 3 and this will be positive 2. This is the answer, the inverse of this matrix. Good luck. I will explain the logs in different videos.